Hi, Ricky here. This is LeetCode question number 885, Spiral Matrix 3. This is medium difficult question. Let's get into it. Okay, on a two-dimensional grid with R rows and C columns, we start at R0 and C0, facing east. East is here. East, west, south, north. Is following the map of the direction. Here, the northwest corner of the grid is the first row and columns, and the southeast corner of the grid is at the last row and column. Now we working clockwise spiral shape to visit every position in this grid. Whenever we would move outside the boundary of the grid, we continue our work outside the grid, but may return to the grid boundary later. Eventually, we reach all R times C space of the grid, return the list of coordinates representing the position of grid in the order they were visited. Okay, let's check with the example 1. Input is R is 1, so R is 1, and column is 4, and start with 0, 0. So start with here, and then next move east. So now is 2, and then 1 around it visit 3, and then 1 around it. Finally, it visit 4. So we need to return each coordinate. 1 is 0.0, and then 2 is 0.1. This is row and this is column. So next 3 is 0.2, and then last 4 is 0.3 because column start with 0, 1, 2, 3, and then 3 is this one. And let's example 2. This is much larger than example 1. Okay, input row is 5 and column is 6, and then start position is now row 1, and then column 0, 1, 2, 3, 4. So here to here, start with here, and then it start the facing east, and then length is 1, and then change direction 1 time. Length is still 1, and then change direction 2 times. In this time, every 2 times change the direction, we need to increase the length. So length is now is 2, and then 2 times passed. Now next is 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. So now I think we can find some pattern. First is the facing is east, start with direction is east. So, and then maybe we can make the movement, the row and column, and then next we need to remember maximum length. And then current length too. Maximum length start with 1, and then if direction change every 2 times, maximum length needed to increase 1, and then finally we can move like spiral matrix. Does it make sense? Alright, let's implement with this approach. First, okay, we need the one array, name is move. This is two-dimensional array. So first is the left. Okay, let me use tuple because this value did not change. So tuple in tuple is okay. Let's test. I never test tuple in tuple. 0, 1. This is left. 0, 1, 0 is down. Is south, and then west is 0, 0, -1, and then finally north is -1 now, 0. Okay, and then direction is start with 0, and then this one is east. So this direction is needed to think of this one. So this one need to move the east. East means the lowest did not increase and decrease, and then only column needed to increase plus 1. Is it make sense? Okay, next we need to define max length. This one restricts movement each direction. First is max length is 1, and then we will charge next with max length. And then now we start with R0 column, start with C0, and then out we need one array to output. And then first we need to iteration while length of output below are the item, the number length of item in matrix is R times C. And then okay, let's move while our length is not 0, and then every time we need to decrease length 1. First, okay, we needed to add from start point, right? This one start point 1 is 4, this is 1 first. So first we need to add output. Before that, we needed to check that item is in matrix or not. So we need to now must be 0 with R, and column also same as higher than 0 and then smaller than C. At that time we needed to push this coordination to output row and column. And then let's calculate the next move. I needed to be move direction, and then now is the 0 index column move direction is 1. Okay, and then we needed to decrease length, and then after finish the length, we needed to charge length with max length. And then before that, every two change the direction, we needed to add max length plus 1. So if max length is odd, and then we needed to not max length, direction is 1, max length plus 1. Why this is 1? I think this is even. Okay, some people got question like this, but let's see. First direction is 0, right? And then this one is the moved, finish it right here, and then next is change direction here. Now we here. So two direction is passive, but direction is did not change it. So it is time, if this is the odd, such as 0 and this direction is 1, we needed to add increase max length plus 1. Does it make sense? Alright, and then let's refill the length. Length refill with the max length. And then change direction. Direction plus 1, and then this must be less 4. And then I think we done. Okay, let's check. Length charge it, and then allow column. Okay, updated, length updated, and then length and direction update. I think we done. Just last is return up. Okay, let's check. Let's check. Okay, that's this typo. All right, accepted. Oh, okay. Runtime is not bad. Oh, memory usage is best. Okay, efficiency is I think this is linear time because there are one iteration. Actually, this iteration is larger than row and column. That means if the number of rows is m and then number of column is n, this is bigger than m times n, but I think this is the less than 2m times 2n. So we can say it is m times n because the 2 is the no meaning. So that is the reason why I think the time complexity is linear time, and then the space complexity is constant space because we do not use any extra space, extra data structure. Thank you.